The 230M Giant Killer. Liquid AI's 230 million parameter model just beat Google's Gemma 3.1b in data extraction accuracy while using 60% less memory. On a Raspberry Pi 5, it hits 42 tokens per second, proving that architectural density matters more than raw parameter count for edge deployments. This release marks the first time a sub-300 million model has shown parity with 1B-class transformers on structured tasks. The secret lies in a structural departure from the standard transformer block that has dominated the field since 2017, the KV Cache Bottleneck. Transformers are fundamentally inefficient for edge devices because the KV cache grows with context length, quickly exhausting the limited RAM of a smartphone or robot. LLM 2.5-230M bypasses this by using a hybrid backbone that replaces the majority of attention layers with gated short convolutions. This architecture maintains a stable memory footprint under 400 megabytes regardless of how long the conversation runs. By removing the linear scaling of the memory buffer, the model avoids the hardware-level bottleneck that usually forces developers to choose between context window and speed. It turns out that for tactical data tasks, you do not need global attention at every layer. The next factor in this performance is the sheer volume of data compressed into those parameters. 19 trillion token density. Scaling laws usually focus on parameter count, but Liquid AI trained this 230 million parameter model on 19 trillion tokens. That is a ratio of roughly 83,000 tokens per parameter, which is nearly 40 times the density of earlier open-weights models in this class. This high-density pre-training allows the model to develop a robust internal representation of structured formats like JSON and YAML without the bloat of a multi-billion parameter footprint. While this model does not have the deep reasoning capabilities of a 70B model for creative writing, it is functionally superior for the narrow, high-frequency tasks that power autonomous agents. Critics argue that such dense training might lead to overfitting on specific formats, but the benchmarks across diverse schema extraction show that generalization holds. This density is the prerequisite for the shift toward local agents. The shift to edge-first design. The LLM 2.5-230M release indicates that architectural efficiency has finally caught up to the hardware constraints of 2026. By solving the KV cache bottleneck and utilizing extreme token density, this model enables what Liquid calls AIETL, where data processing shifts from rigid scripts to adaptive local systems. This means a humanoid robot or a low-power sensor can now structure unstructured data locally without a cloud handshake. For developers, the takeaway is that on-device performance is no longer a matter of making a big model smaller, but of using models that were never big to begin with. We are seeing a transition from general-purpose giants to specialized micro-models that prioritize throughput and power efficiency over parameter vanity. This move toward non-transformer hybrids suggests the future of edge AI will be defined by tokens per milliwatt rather than just leaderboard rankings. Watch for the immediate adoption of these models in industrial robotics, where sub-millisecond local inference is a safety requirement. The era of the cloud-dependent agent is ending for the physical world. Subscribe for more.